Hi everyone, Professor Bob Young here. In this instructional video, we're going to discuss polar coordinates and polar equations. Now in your supplemental handouts in the course, you have a piece of paper with polar coordinates on it, polar graphs, which some of you may have never been exposed to before. So this is why we go to college and learn things. All right, now in the polar coordinate system, we're going to consider this the x-axis and this the y-axis, but in polar terms, the x-axis is called the polar axis. Okay, so we'll go ahead and name it x. The y-axis is called theta equals pi over 2, which kind of makes sense to you trig students out there. So we'll go ahead and put y next to it. And the origin is not called the origin anymore. It is called the pole. So we'll make a note over here. The origin is where you begin graphing, and it is called the pole. So what I want to do first is just get you kind of comfortable with plotting polar coordinates on this polar paper. And when you plot them, you have it in the form r theta. So we're looking at the angle and how far out we're going to go for a radius here. So what I want you to do here, I'm just going to run through some with you, and I'm going to give y'all some to try as well. So in the first example, we're going to say 3 pi over 6 radians. Now here again, you must know where your angles are on your circle if you're going to be successful here. So pi over 6, you should know, is here. So we're going to go from the pole 1, 2, 3. And that is all it takes to plot a polar point. And what I'll do is I'll just put A next to it. All right. Now also notice that you have your quadrants here. So this would be a point in quadrant number 1. And then we'll go around the horn, quadrant 2. But we have seen these many times. Quadrant 3. And in the homework, you'll actually have some problems just asking you which quadrant some of these values and points are in. All right, quadrant 4. All right, let's continue. Let's plot the point 2 pi. So what you do first is you know where pi is. You kind of go where the angle's at first, and then from the pole, you go out 2 and put your point there, and we'll call that B. C. Now, Young, what if they give me a negative angle here? Don't panic. Now, remember negative angles, and this is kind of good exam review. You go in the clockwise direction, not counterclockwise. So where is negative 5 pi over 6? So negative 1 pi over 6. Negative 2 pi over 6 is negative pi over 3. 3 pi over 6 negative, negative pi over 2, 4. And then 5 would be here. So we're just going to go out 1, 2, 3, 4 circles, and that would be point C. So you can have angles either positive or negative going out a certain R value from the pole. All right, let's try D next, point D. And if you want to, you can start pausing and trying some of these yourself. I'm going to give you that opportunity as well. So negative 3 pi over 4 would be, again, going the clockwise direction. Negative pi over 4. Negative 2 pi over 4 is negative pi over 2. Negative 3 pi over 4. From this angle, we're just going to go out 1, and that would be D. Now, Young, what if they give me both a negative angle and a negative R value? What happens with a negative R value? Well, let's think about it. All right, so for the last point, I'm going to go negative pi over 2 radians here, which would be down this direction, okay, negative 90 degrees. You might even see some of these in degrees as well. So we'll say negative 90 degrees. Now, if we were going out like the previous examples, if we went out a positive 3, it would be this direction. Now, guess what happens if it's negative? Some of you may see that it's going to reverse it this direction. So a negative R value will take and flip the direction 180 degrees. So that would be our first set of plotting polar coordinates in the polar graphs. All right, here is the next set of points to plot here. So we must become very good and adept at plotting these polar coordinates. So on a piece of polar graph paper you can get in your supplemental handouts, I want you to go ahead, pause the video, and try to plot these 5 points. And I threw some in terms of radians and some in terms of degrees just to be make sure you're on the ball with things here. So I'm going to pause and come back and do it with you. Just take a minute here. All right, so let's see how you did. If you haven't done it yet, go ahead and pause again and come back. But I'm going to go ahead and run through this one. So for 2 pi over 3, 2 pi over 3 is this angle right here. Go out 1, 2, 3, 4 circles, and notice I'm using colors again. You guys know I like my colors. Point A. All right, B, 3, 135. So I went degrees on you here. So remember, every 45 is halfway through. 45, 90, 135 is here. Go out 1, 2, 3 circles. So again, knowing that unit circle, it just continues to be an important very important in the course. All right, C, negative 210, where's that at, Young? Well, we got negative 90, negative 180 would be negative pi, and then another negative 30 here. Young, it looks like you're crowding these points together in this one. You're all getting them in quadrant 2, and then just go out from negative 210, 2 circles. So I hope y'all are 3 for 3 now. Now, if not, don't get discouraged. You know, you'll get plenty of practice on these, I promise you. All right. For negative 5 pi over 6. Now remember, if we went the counterclockwise direction, 5 pi over 6 would be over here. So we're going to go negative 5 pi over 6, which would be here. And that looks like we're going out a positive 1 circle. So this would be D. And then the last one, we're going to do both a negative angle and a negative R value. Okay, so you can do either. Now, where is negative 300? Well, all the way around the circle going this direction would be negative 360, negative 2 pi. So I'm backing up 30. Now, if I was going a positive 1, 2, 3 here, I would be going this direction, but negative again takes it, so I would back up 1, 2, 3 this direction. And how did y'all do on this one? Did you get 5 for 5, 4 or 5? Now, if not, don't worry about it. We're going to go ahead and practice some more as well. All right, so going through the homework here, we'll just go ahead and take a few examples and do them here. It says for the polar point 5, 135 degrees, just go ahead and indicate which quadrant that's in. So hopefully you know that 135 lies in quadrant 2 here. So I told you the first few examples are going to be kind of nice, and it actually shows you where to plot that point and so forth. And then they're going to try to reverse you with that negative number in there. So if you were thinking about going 135 degrees in the second quadrant and you went the negative direction, think about where you're at now. And if you want to, you can go ahead and plot those on your polar paper as well. But I hope you would end up in quadrant 4. And again, it'll kind of show you how that is accomplished there and give you some good direction. All right, now another one, just to make sure you get this negative addressed here, these negative R values, if you go pi over 4, that would be a first quadrant angle, but when you negate it, you should be where? In quadrant number 3. All right, the next example, they're just going to give you some polar points and have you choose the correct polar graph here. So if we went 7 pi over 4, which would be in quadrant 4 here, so if I went all the way around, so I'd probably be looking at something like this. So this would look like it would be a positive 4, 7 pi over 4. But the negative value, I think I'm going to go with choice C here. So there's going to be a whole bunch of opportunities to go through this homework like a hot knife through butter. Okay, so now if we say 3 pi, so we would start and go a positive direction on pi here. Now, obviously the A is not the correct choice there. So B, I'm looking along pi here. I'm thinking that that looks like the 0.3 pi. So they're just going to give you polar points, just again to get you familiarized with the graphs. All right, negative 45 degrees would certainly be going this direction here. And if you went out 4 positive R values, I think this would be your choice here. All right, the next topic we're going to look at, now in the rectangular coordinate system, when we're talking X and Y's, like if I take the ordered pair 2, 5 in the first quadrant, that is a unique point in the rectangular system. Now, polar points, on the other hand, are a little different, and we're going to look at those now because there are infinitely many polar points that can be assigned to a given polar point. So let's see how that is done next. All right, I'm going to go ahead and take an R value here. I'm going to put R theta as we have been practicing thus far, and I'll take the 0.2 pi over 4 here, the polar point, which we could also write, depending if we wanted to go degrees, as 245 degrees. So from the pole and 45 degrees, I'm just going to go ahead and plot this point and show you some interesting things that go with this. Now, R theta, I'll come over here on this side, can also be written, the same polar point can be achieved, and I think as we have progressed in the course, you'll understand this very well. If you take that angle and you add or subtract 2 pi n, now if we're talking radians there, that would work. Or if we're talking degrees, you would say R theta plus or minus 360 degrees n. All right, now n being an integer, 0, 1, 2, negative 1, negative 2. So for example, if we were here at 2 pi over 4 and we added 2 pi to that, so let's just come over here and do that real quick, we would be at the point 2,9 pi over 4. So remember, 2 pi, if you changed it into force, would be 8 pi over 4. Okay, so you could just keep adding 2 pi, 2 pi, 2 pi to that, or you could subtract 2 pi, 2 pi, and you will still have the same polar point. Now, you could go crazy on this. You could add another 8 pi over 4 there. You could say it's 217 pi over 4. So that's the periodic nature of our trigonometry that we have discussed earlier. You could subtract 8 pi over 4 from that. You could get 2 negative 7 pi over 4. And let's see if that makes sense to y'all. So if I wanted to plot this polar point, I would go negative 7 pi over 4, land here, go out 2, and there you go again. All right, so this is one way you can keep writing polar points. Now again, I could do it with degrees as well. I think y'all see that. I'll take 360 and add it to this right here, and you would get the polar point 405 degrees. All right, so that's just adding 360, adding, and you could subtract 360 and so forth. All right. Now next, I'm going to stay with the same point here and see how you look at this. You can take any polar point and instead of adding or subtracting 2 pi n or 360 degree n, there is another way you can arrive at the same polar coordinate. If you negate the R value, and on the angle, you can add or subtract pi radians. All right, now of course in degrees, here's what this would look like, and then we'll show you how this works as well. We can say negative if the R value is negated and you add or subtract 180 degrees, how this will work. All right, so let's just go ahead in degrees on this one, and we will put, this is the point, we'll just stay with this one for demonstration purposes, 245 degrees. All right, now I'm going to go ahead and negate this R value, which I'm going to change it to -2, and I will add 180 to this, so that'll give me 225 degrees. At least I hope my addition is correct here. So anyway, if we went 225 degrees in terms of 45, 45, 90, 135, 180, here's our 225 degree one here, and we backed off -2, oop, there it is. Oop, there it is. Don't get me started on singing songs now. Yeah. Now, also, you could add 180 to that, and you could say that this is -2, and then 180, or I'm sorry, if we subtract 180 from this, what am I saying here? 45 minus 180 would be what? Minus 135 degrees. So you can add or subtract here. Now, where's minus 135? -45, -90, minus 135. If you back off 2, there it is again. So there are infinitely many ways to write a polar coordinate. I mean, you could put so many different ones on there, it would be mind-boggling. But let's not go there. Oh, I just thought of something on the exam review here. These two angles, 225 degrees and -135 degrees, are called what kind of angles? What's that name? Coterminal, perhaps? Oh, yeah, there's a good little exam review question right there. So let's get back to the homework here and see what's going to transpire from this. All right, so looking at the homework problems here, they're giving us an r theta here, and they're saying, what happens if you say theta plus 2 pi? And they will try to give you some distractors in here, but hopefully you know, well, if you add 2 pi to it or any increment of 2 pi, you're going to end up with the same r value there. And they're saying, great there. And I just caught something on the video. I can't believe I did it. But let's just look at this answer here, and I'll go ahead and correct that immediately here. All right, if you have r theta here and you add pi to it, what's going to happen? All right, I think most of you know we have to negate the r value there. So let me go ahead and show you that is also correct. All right, now we've already done that one. Let me back up here real quick, and I want to get back to this problem. All right, so to correct my error, it wasn't a bad error, just a little one now, but I caught myself. All right, r theta can be written as, you can negate the r value and put theta plus or minus pi n. It's like, Young, how'd you forget the n on that? Remember, it could be 180, 180, 180, or 180 degrees n when you negate the r value. So I stand corrected now on those. All right, for our next topic, I want to now relate the rectangular coordinate system to the polar coordinate system. So we can revert from one to the other. We'll actually show graphs that have transpired polar graphs on top of rectangular graphs. And then we're going to show you the proof for what I call the Fantastic Four polar equations. And we'll get to that here. All right, so I'm just taking a right triangle here in the first quadrant, and as we have done many times before in the course, I'm going to call this angle theta here. I'm going to call this side along the x-axis x, this value y as it corresponds with y, the y-axis over here, and I'll call the hypotenuse of the right triangle r. All right, so let me come over here and we will look at what I call the Fantastic Four. I was one of my childhood favorite comic books to read, and I always liked the Fantastic Four, so I hope everyone would agree. And this is another good exam review concept right here, that the sine of angle theta would be opposite over hypotenuse, y over r, okay? The cosine of angle theta, adjacent over hypotenuse, would be x over r. So if we wanted to solve this for y and this for x, I hope everyone sees that y would equal r sine theta, x would equal r cosine theta by multiplying through both sides by the common denominator of r. So these first two equations are what I'm calling the first two of the Fantastic 4. All right, continuing. So this is a little something you can remember very easily here. I'm going to say the tangent of that angle theta would be y over x. Now there's a few ways we could get it. Sine over cosine, opposite over adjacent. We have learned many ways to do these. And the last, so this is equation number 3 of the fantastic 4. And equation number 4 would be, I think everyone would see this one from the Pythagorean theorem, x squared plus y squared would equal what? R squared. So ladies and gentlemen, these 4 equations Young is going to deem as the fantastic 4. And yes, there they are. Sue Richards, Reed Richards, Johnny Storm, the Human Torch Flame On, and the Thing, Ben Grimm. I'm calling those trigonometric equations. I'm sending up the 4 signal right now. So we will move on and see how this works as we progress. All right, in the next few examples, we're going to change from polar coordinates to rectangular coordinates using our newfound formulas, the Fantastic Four as we call them. So we'll start with this one. It says, find the rectangular coordinates given the polar point 3, 270 degrees. Alrighty, so I went ahead and I wrote in terms of r theta the given polar point 3, 270 degrees, and I wrote the first 2 of the Fantastic Four formulas here. So I'm going to shoot up the 4 sign. So I'm going to say x then equals r is 3 times the cosine of the angle given is 270. Y equals 3 times the sine of 270. And again, you must know your unit circle values here. The cosine of 270 is 0. So we end up with 3 times 0. The x coordinate of this would be 0. The sine of 270 is -1. So y would equal 3 times -1 or -3. So we end up this polar point becoming this rectangular point. Now remember, 0, 3 is a unique point. It is the only one like it. But this point, this polar point, can appear in many forms. You can add and subtract 360 degrees endlessly on the angle. You can negate the 3, the r value, and then add or subtract 180 endlessly and get the equivalent polar points to that. So always keep that in mind. And I also wanted to show you the graphic interpretation of this. All right, so we just found out that polar point 3, 270, if we graphed it, we would start on the positive x-axis, go counterclockwise to 270, and from the pole, we would go 3 that direction, positive 3. Now notice this rectangular point, if we were thinking just the old XY coordinate system, 0, -3, we're landing on the same point. So I think this is a great way that you can see the relationship between our XY values and our polar values if you have like a superimposed graph like this one. All right, so we'll go ahead and check this one. And I think we're in good shape. Now I'll go ahead and pause and I will let you try this next one. So again, label this polar point r theta. See if you can get the rectangular points that correspond to that. I'll go ahead and pause and I'll work this one with you and we'll come back together and make sure we're on the same page. All right, so coming back at you here, I labeled this point r theta. I wrote the Fantastic Four formulas here again. X equals r cosine theta, y equals r sine theta. And I went ahead and plugged in the 2 and the 7 pi over 6. So the cosine of 7 pi over 6 is minus square root of 3 over 2 times 2. The 2's cancel out, leaving you with minus square root of 3. The sine of 7 pi over 6 is -1/2 in the third quadrant times 2 would get you -1. So hopefully you arrived at this answer. All right, so checking that, we're still good to go here. Now, next up, it gives you a polar coordinate 7.2, 2.9. Now, you would do this the same way, except it wants you, this is not a nice unit circle value like the previous two examples. Now, the thing here on theta, when you do your x equals r cosine theta, y equals r sine theta, be careful you're in the correct mode here. Are you going to be in radians or degrees? Think about it. Now remember, a radian is a number measure, so this would be in radians when you do it. So when you get that answer, watch out there. All right, in the next few examples here, we'll go ahead and we will change from rectangular to polar coordinates. Now, if we're given the ordered pair -3, 3, we know we would be up here in the second quadrant. All right, now what we're going to need on this one is the other two formulas for the Fantastic Four. We're going to have to get the r value here. Remember that x squared plus y squared is going to equal r squared. So we'll go ahead and plug in -3 for x and +3 for y to get r squared. So this will give us r squared will equal 18. And then taking the square root of both sides. Now remember, the radius is always going to be a positive number because it's the hypotenuse of that ordered pair. And this would simplify the square root of 9 times the square root of 2 is 3 times the square root of 2. So that's your first value. Now to get the angle, remember the other part of the Fantastic Four, so we used this formula here to go the other direction. We will say the tangent of theta equals y over x, which in this case is 3 over -3, which will reduce to -1. Now, how do you get theta? What undoes the tangent? The inverse tangent, arctangent, or what I like to say, the angle getter. So the inverse tangent of -1, now be careful, your calculator is going to give you this -45 degrees down here. And of course, if it wants radians, you'd have to put -pi/4. But again, and this is some of your weaknesses here, you have to know that you are in which quadrant here. So when your calculator gives you this -45 degrees, you need this angle up here in the second quadrant. So you're going to have to add 180 degrees to that, which will get you 135 degrees, or 3pi/4 radians. It'll tell you usually which one it wants it in here. So you can also use the reverse process to go from rectangular to polar points. So the Fantastic Four can take you both directions. All right, now to finish out the section polar coordinates, we are now going to take some rectangular equations in terms of x, y, and change them into polar equations in terms of r theta. All right, so here's the first example we're going to look at here, and we'll look at maybe 3 or 4 of these at least. So it says convert the rectangular equation to a polar equation, 3x plus y equals 10. All right, so I went ahead and I wrote the 4 equations here relating polar and rectangular coordinates. So if I want to get this one in terms of polar, I think you're going to see we're going to have to substitute for x, r cosine theta here. So I'm going to put 3, and instead of x here, I'm going to substitute r cosine theta in there, plus y is going to be r sine theta. So on some of these equations, when you're going from rectangular to polar or back again, you're going to have to look at the relationships here very carefully and use some wisdom in order to do it. Now notice they want you to solve this equation for r. So what we're going to have to do is factor a common r out of this trigonometric binomial here. So if I factor an r out, and we've seen this before in some of our previous lessons, we'll get 3 cosine theta plus sine theta equals 10. Now, of course, you can check this by distributing, and then r by itself would be divide both sides by the 3 cosine theta divided by or plus sine theta. So here is your answer. Okay, so that's what we'll go ahead and type in here and check it. Now in class sometimes I'll forget to pull this up and show the students when I'm doing it, just to show them that it really will work. And I'll go bang when I get it right. It's a good feeling when you get them. All right, so let's try a few more. All right, in this one, y equals 5. Now, what does y equal here? If you're thinking about our top 4 friends and equations, r sine theta would equal 5. So remember, y, whenever you see that, will be replaced with this. If you see x, r cosine theta. And then again, if it wants in terms of r here, we're going to divide both sides by the sine of theta. So this would be our answer for r here. So again, remember, not always in the polar equations will you have both a sine and a cosine in there. Just like in rectangular equations, you may not have an x and a y in there on those all the time either. You might have y equals 7, 2x equals 4, something like that. I mean, you might not always have both x and y's here, so don't always assume you've got sines and cosines in every one here. Okay. All right, in this example, it's got x squared plus y squared equals 81. Now, this is one of the most fundamental ones right there. If you ever get an x squared and a y squared and you're trying to write the polar equation, remember, x squared plus y squared equals r squared equals 81. Take the square root of both sides, r would equal 9. And again, the radius, you always want to keep that positive answer whenever you're putting it in there. All right, let's see what else we've got here. We're almost to the end of this thing. Now, they are going to keep hitting you with these things, so we'll keep continuing and do enough of them so y'all will feel good. All right, for yet another example here, if we have x squared plus y plus 7 squared equals 49, and we want to write a polar equation for this, I think what I would do first is FOIL that y plus 7 there, or multiply the binomial square together, y plus 7 times y plus 7, which will give us y squared plus 14y plus 49 equals 49 here. So this one kind of foiled out, or the binomial when you squared it came out kind of interesting here. Now, I think most people are going to say, well, when you subtract the 49s from both sides, the numbers kind of drop out of this one, all right? And you will have x squared plus y squared, which I'm thinking if you're looking up here among these four, it's like, and you might start seeing some things, plus 14y equals 0. Now here, x squared plus y squared, remember we want everything in terms of r, is r squared, plus 14y, which one would you start looking at up top there? I'm thinking, okay, 14 r sine theta equals 0. Now again, you can factor an r out of here and get r plus 14 sine theta. And of course that equals 0. Now an r value of 0 is not really going to help you write this equation if you put r equals 0 there, because you want something in terms of theta. So remember, you can take each one of these and set them equal to 0. So I think this is going to be our boy here that's going to help us get the equation. All right, so r, subtracting this from both sides, would be negative 14 times the sine of theta. All right, so some of these look a little bit scarier than others, but they're really not that bad. And bang. All right, finishing out the lesson, let's look at one more example that may cause some issues for some people. What if they just give you a simple r equals 11 and they want this rectangular equation for that? All right, so when you look at this one, r equals 11, I mean, what do you do to get this in terms of a rectangular equation? Well, I could say that, well, here, this has got an r in it. R would be x over cosine theta, but then I still have the cosine of theta in there. It's not in terms of x and y. Same for this one, I could solve for r. This one, oh, if only I had an r square, then I could do something with that one. And then this one, I really don't think it's going to help us in terms of this. So what I'm going to do is saying, well, I don't have an r squared given, so what I'm going to do is make an r squared. I am going to square both sides of this equation. So in some of these, you may have to do some manipulations and say, well, that would give me r squared equals 121. And then if you want rectangular out of this, we will take r squared and replace it with, I bet you know what up here, x squared plus y squared equals 121, which it looks like to me would be the equation of a circle with a radius of 11 here. So we have gone from rectangular equation to polar, and now we're going to go from polar back to rectangular to finish it out. All right, so that works well. And now notice they're bringing up some graphs here. Hot diggity. So they want you now to go ahead and find the equation of this rectangular creature here, which we said was a circle with a radius of 11. So I'm thinking that's got to be choice B here. So they might even give you a little bit in the past to come back and do this. All right, now the next example we're going to look at is theta equals 7 pi over 6. All right, now in this one, what I'm going to do here is I think I'm going to look at the Fantastic Four one more time and see if y'all will agree which one you would use on this one. All right, so sometimes students, when they're going from rectangular back to polar, they don't see things quite as well. But if I look at these four, I want you to pause a second, think about which one you would use. I mean, you can freeze the frame, but you know, there's lots of different things you can do on this, but what I think you're going to have to do is take the tangent of both sides of this equation, because if I do that, I think I'll see something here. So I'm just going to say the tangent of theta would equal the tangent of 7 pi over 6 radians. And you know what we're going to get to do here? Gee, what number could that possibly be, Young? Well, that is the sine of 7 pi over 6 radians divided by the cosine of 7 pi over 6 radians. So once again, knowing our circle, we would have negative 1/2 divided by negative square root of 3 over 2, okay, which would equal what here? 1 over the square root of 3. Now, once we get to there, we can say, well, the tangent, if we want this in terms of x, y, we could take and say, well, tangent is y over x, and we just found that that equals 1 over the square root of 3. Okay, so if we multiplied by the LCD here of x, we would get y equals, and we might want to go ahead and rationalize this denominator here, because most of the time, you know, if you don't rationalize, you can be in trouble here. I'll go ahead and make that 1 over the square root of 3, the square root of 3 over 3. So multiplying by the LCD, y would equal the square root of 3 over 3 x. So once again, we're going from polar to rectangular. All right, now make sure you don't put y equals in here either. Sometimes students do that and they get it wrong and they get all bent out of shape, and you know, the y equals is already there, so beware. It could possibly be, I'm going to have to blow up a here again. So, okay, so the y-intercept would be 0, so I guess if I rised and run, it would have to be choice A there. I almost got thrown off the scent there for a second. Sorry about that. I've been doing too many videos for too many days. All right, good. All right, this will be our last example here, and once again they want us to convert the polar equation to a rectangular equation, so we're going to look at this last example, and hopefully that will be enough for you to complete the rest of the homework and assignments and so forth. All right, so you will probably have this dilemma in more than one problem. It looks very easy when I do these. I know it, and I tell students in class that. And a lot of times in class, of course, I'll stop and give students time to work on problems in class, and we'll go over them together. So when they get home, they don't go, But it's nice about the online and video courses. You can stop and pause and see if you can figure it out first, and then go from there. Now, if you can get this one, I'm going to be very impressed. All right. Now, again, if you're looking at these, it's like, well, this would be great if there was an R in here with the cosine, the 6 cosine theta, but there's no R. This one, it would be nice if there was an R in here. I actually almost put an R in that one. Sorry, you can't just do that. But if you multiplied both sides of the equation by R, and again, you're going to have to play with these and kind of reason things out when you do them. It takes a little finesse. You'll get R squared equals 6 times R cosine theta plus 2 times R sine theta. And now we're in business, because now I can change all of these into X and Y's. I know that R squared is that one there. I'm going to substitute in X squared plus Y squared. I know that R cosine theta is X. I know that R sine theta, so you're trying to manipulate these into getting nothing but X and Y. So now if we want this equal to 0, we're going to say the final answer, X squared plus Y squared, subtract 6X, subtract 2Y equals 0. All right, this concludes the instructional video. Polar coordinates, Bob Young signing off.